So the next topic we're covering is the concept of stroke volume, and then we're going to get into cardiac output, which will be a recurring theme throughout the entire semester, so pay attention. It's not the most interesting of topics, so I want you to really be present to this video, and I'll make it nice and short for you. We're going to be doing actually quite a lot of work around stroke volume and cardiac output, so I think one of the ways to stay present might be to think about why it's important. Why do we care about these topics? So, stroke volume, which we're going to abbreviate SV, is the blood pumped out by a ventricle with each heartbeat. The way that we calculate stroke volume is by subtracting ESV from EDV. So the formula is SV equals EDV minus ESV. Again, SV equals EDV minus ESV. So what are these things? So let's start with EDV. EDV, end diastolic volume. This is the blood that collects in a ventricle during diastole, which is the resting phase of the heartbeat. The next one is ESV, end systolic volume. This is the blood remaining in a ventricle after a contraction or after systole. So again, SV equals EDV minus ESV, and if we want to take just an exemplar and go ahead and write it down so that we can start to work with these numbers and change them a little bit under certain conditions and explore what happens next, I want you to at least have that hypothetical, typical situation. So the metric is very important here. The metric is milliliters per beat, ml per beat. So typically your EDV on average would be about 120 milliliters per beat. Your ESV would be 50 milliliters per beat. So if your EDV minus your ESV equals your stroke volume, then calculate, if you would, the stroke volume in this particular instance. And then, going a little bit further, we have to think about cardiac output. Cardiac output, which will henceforth be abbreviated CO, is the amount of blood pumped by each ventricle in 1 minute. Now this is different. Stroke volume was talking about 1 heartbeat. Cardiac output is talking about 1 minute. Difference. So the way that we calculate cardiac output is we have to calculate the stroke volume first, and then we have to multiply that by the heart rate. So SV times HR. And pay attention to the metrics. We'll do some examples of this in class. A typical heart rate would be about like 60 beats per minute. So the metric here is beats per minute. Okay, or maybe 70. Let's do 70 beats per minute. I just think that makes more sense in a general sense. Okay, now there are 3 factors that affect stroke volume. Preload is the degree of stretch of heart muscle prior to contraction, and this can be enhanced by a slow heart rate, which would cause an enhanced venous return. And your preload is actually diagrammed here, kind of the idea behind it here. The degree of stretch of the heart muscle before contraction. The next concept, the second factor that can affect your stroke volume is called contractility, which is actually a really easy one to understand. Contractility is basically the strength of the muscle of the heart, so the strength of the myocardium itself, and the ability to contract hard. So contractility can be greater or lesser. If you have more vigorous contractions, this generally allows for more blood output. And lastly, we have afterload, which is described sort of in this picture here. Afterload is the back pressure that is exerted by arterial blood. More blood pressure. So when we talk about arterial blood, we are describing what we commonly understand to be our blood pressure. More blood pressure will reduce the ability of the ventricles to actually pump the blood out. So here we have our right ventricle trying to pump blood up through the pulmonary semilunar valve. Here we have the left ventricle trying to pump blood up through the aortic semilunar valve, and you can see the very distinctive aorta there. And what you'll see here is that there's this black arrow here kind of pushing back in the opposite direction. That is a perfect exhibition of afterload. So the blood pressure there, you know, the more blood pressure you have, the harder it's going to be to pump blood outward against it. So for each of these, preload, contractility, and afterload, I want you to consider which of the factors of stroke volume would be more affected in each case, ESV or EDV. And then I want, you know, we're going to be doing some examples in class where we sort of play around with the numbers a little bit. But if you want to do that before class, especially if you're kind of struggling with the concept, sit down with this, think about which number would change and then change it by, say, 10. And then take a look at what happens next. How does that eventually affect stroke volume? How does that eventually affect cardiac output? We'll do these in class too, but you know, a good way to prepare for class is to try to do a little bit of the work ahead of time. Really sit with, especially if you're uncomfortable with it, even more important to really sit with the problem and give it a go.